Today we will discuss what is Hall effect. When current carrying conductor is placed in a magnetic field, a transverse effect is noted, and this is called Hall effect. And it is discovered by the Hall in 1879. And according to Hall, he found that when magnetic field is applied at right angle to the direction of electric current, an electric field is set up which is perpendicular to the both direction of electric current and the applied magnetic field. So this is a finding that is found by the Hall in 1879. In other words, when a specimen carrying a current I is placed in transverse magnetic field B, then an electric field E is induced in the specimen in the direction perpendicular to both I and B, and this phenomena is known as Hall effect. So with the help of diagram we try to understand what is Hall effect. This is a specimen bar, and the depth is D and its width is B. These are two faces, face 1 and face 2. That is semiconductor bar. In X direction we have a current, in Z direction that is the magnetic field, and it is the Y direction. So the specimen bar that carrying a current I in positive X direction, and let a magnetic field B be applied in the positive Z direction. So then according to Hall effect, a force gets exerted on the charge carrier, whether electrons or holes in the negative Y direction. This current I may be due to holes moving in the positive X or due to the free electrons moving in negative X direction through the semiconductor specimen. Hence, irrespective of the nature of the charge carrier, whether holes or electron, these charge carrier get passed downward towards face 1 of the specimen as shown in figure. So the current in N-type specimen is carried almost fully by electrons, and these electrons as a result of Hall effect accumulate on side 1, which surface then gets negatively charged related to side 2. And consequently a potential difference develops between surface 1 and 2 and is called the Hall voltage, that is denoted by VH. And this Hall voltage in N-type semiconductor is positive at surface 2, and on the other hand in a P-type specimen the Hall voltage is positive at surface 1, and these two results have been verified experimentally. And generally the Hall effect may be used for determining whether a semiconductor is N-type or P-type, determining the carrier concentration, calculating the mobility having measured the conductivity, and the Hall voltage VH for a given current that is proportional to B, that is magnetic field. Hence measurement of VH measure the magnetic field, and it is also Hall effect multiplier. The instrument gives an output proportional to the product of two signals. Thus, if current I made proportional to one input and if B is proportional to the second input, then Hall voltage VH is proportional to the product of two inputs. So this is all about the Hall effect. What is Hall effect and how it works. Subscribe to get more updates and more video on mechanical topics and Universe 22. You may also like Facebook page www.facebook.com and Universe 22. You share among your friends and students. You can ask your queries by commenting. Give your suggestions if required. Thank you. Have a nice day.